welcome to this lesson on the Unit 1 Number Sense review. As we kind of prepare for the end of the year, it's an opportunity to look back at all the things we've studied and done for the year so far. And so we started the course with a review kind of note on some stuff that we hoped you understood, but I'm just going to quickly go over it again. Okay. So we started with something called integers. So integers are numbers that are both positive and negative, but they are whole numbers. So there's no decimals, there's no fractions, okay? And some rules associated with it. Most of you probably know many of these rules, but I'm just going to kind of review them again, okay? So first of all, if we have a positive and a positive side by side, that's going to give us a positive. If we have two negatives side by side, that's going to give us a negative. And if we have two a positive, and a negative, that's going to give us a negative, and or a negative and a positive, that's going to give us a negative. And these are sort of general rules. So these sort of things start to appear. You can expect um, to see these rules put into place. Okay, so I'm just going to turn my pen back on. Sorry about that. Jumping around the screen here. Okay, so these positive, positive, negative, negative. Sorry, two negatives makes a positive. Positive and a negative makes a negative, and a negative and a positive. Okay, and I'm going to give you two examples here. I'm not going to spend a lot of time on this because I do think that this is something you should have a basic understanding of at this point. But if I have -4 plus -3, this essentially becomes -4 minus 3. These two numbers here become a negative. And these two signs essentially are side by side and they become a negative. And when we have two negatives that are subtracting from each other, I've often said this to students, just add them together and put a negative in front. So -4 minus 3 becomes -7. If you want to think of that from a number line perspective, if this is 0 and you're starting at -4, you're going back 3 to -7. So that's where that logic comes from, okay, if you're using the number line concept. On this question over here, we have two negatives. These two negatives are going to become a positive. So this ends up becoming 7 plus 5, and 7 plus 5 is 12. And once we start to understand the rules of integers, the signs, and how they integrate or work together, it starts to help us with these things, okay? And you will see this throughout your mathematical studies all through high school, and so you're expected to kind of know those things. Another one that I find a lot of my grade 9 students really struggle with are from elementary school. They just don't seem to have this down is the concept of rounding off. And so I'm just going to kind of do a few things now. We don't very often round off numbers to values that are, um, beyond the ones, tens, hundreds, thousands, and whatnot. But once in a while you do. So when you're asked to round off to the thousands, I often say, just, the key thing is circle that number that you're going to round off to, okay, and underline the one behind. And this guy, he's the key right here. If he is bigger, 5 or bigger, this number is going to go up. In this case, he's not. And a lot of times kids will, the 9 is, so that means that the 5 has to go up, and then this goes, no, that's not how it works. Think of this as like, 498. Is that closer to the 1,000, or is it closer to 0? And it's actually closer to 0, so it ends up becoming 45,000 is the answer. And we've rounded that off to the nearest thousand, and it's really important in this case that we add these zeros in here. You'll see that when we go to rounding off, which is much more common to whole numbers or hundreds or tenths, those kind of things, the numbers behind just disappear. They're gone. But we can't do this here because these hold a place value. So 45,000 would be the correct answer. Okay. Essentially, if you look at this question, you could say to a person, well, what do they have? Say they had that money. Are they closer to $45,000 or are they close to $46,000? Well, they're $2 shy of being halfway, and so therefore what you're seeing is that the number gets rounded down. Now, when we round off to the nearest whole number, It's a little easier for students, okay? So again, I'm rounding off to the nearest whole number. I circle that place value. I underline the one behind it, and I say to myself, oh, is that 5 or bigger? In this case, it is. The 6 has really no bearing on this. The 5 is. So that's going to push this up, okay? And it's going to make it 80. And we don't need to put any decimals. We don't put nothing down. We don't even need to write the decimal there, okay? Then when we're rounding off to the nearest hundredth, we have to go to the hundredth. So this is the tenths place value. This is the hundredths place value, the 5. So the 7 becomes the number of interest. So the 7 is going to push the 5 up to a 6. And so we're going to end up with 23.46. And the other numbers behind, they just disappear. We don't need them there. They don't hold a place value like they did up here. So we don't need to put zeros, nothing. If we put zeros, we're misleading people. And it's really important that those zeros do not exist there. Okay, and then there's one last thing that often happens, they like to put into these questions and say we're rounding off to the nearest tenth. Well, that's this place value. It's a 9. And the 7 is going to tell us the 9 has to go up. And the 9 can't go up, okay? Because, well, what's bigger than a 9? So the 9 has to push this 9 up. Well, that one can't go up, so it has to push this one up. So we end up with 40, in this case, 0.0. And this time we do put this place value in for the tenth because we are rounding to the tenth, even though it is a 0, and that's okay. And basically, that's the closest tenth place value that we get to from 39.9721. Again, lots of practice really helps when it comes to rounding off. So if you look up some rounding off worksheets, not a lot of questions on your exam, but it's usually for most kids a fairly easy way to go. Okay, then we have percentages, and so converting to a percent. Okay, in this particular case, to convert this to a percent, we're going to take 32 and we're going to divide it by 45. That's essentially what this means. And to make it a percent, we're going to multiply by 100. And this is usually a calculator thing. So if you got 32 out of 45 on a test, you can calculate your percent by going 32 times, or divided by 45 equals 71.1111. And once we multiply it by 100, you have to multiply it by 100. And so it comes out to 70.1.1111. And usually we just round off to the nearest percentage, whole percent. When converting from a percentage to a decimal, it's essentially we're going to divide by 100. And this is going to be 0.43. The other way looking at it is the decimal place moves over 2, okay? And this is critical because whenever we want to use percentages in a question, like the next one, we want to be able to calculate it mathematically. We need to convert it to a decimal. So if this question here, I want to find out what my tax is on $13.99. Well, my tax is going to equal $13.99 times 13%, which is actually 0.13. And so I can do that calculation on my calculator again, and then go 13.99 times 0.13. Pretty straightforward. And that works out, we have to round it off to the nearest penny, so it's $1.82. Okay. And then if I wanted to, I'd have to add that to my item to get the cost. So if I wanted to find my total cost, it would be $13.99 plus $1.82. Okay, and so if I add those two together, I get $15.81. That equals $15.81. Okay, if you're asked to do that. And there are a couple questions like that that we sometimes throw at people to help demonstrate their understanding of percentages. Now, the biggest part of this unit by far is doing fractions, okay? And this seems to be, a fair bit of a challenge for students, okay? So let's look at a number of different things from lowest terms to mixed and entire fractions, and then multiplying, dividing, adding, and subtracting fractions, just to do a quick review. So when we want to put things in lowest terms, we want to look to see if, in fact, these numbers have a common number that is divisible by both. And so as long as we do the same to the top and bottom, we're okay. So in this particular case, both can be divided by 2, and that gives us 5 over 9. And 5 over 9 is the exact same value as 10 over 18. And if you were to take 5 divided by 9 or 10 divided by 18, you get the same answer. This is considered lowest terms because the numbers are in their smallest format. Then we also get sometimes ones like this. Well, we'll get students will go, oh, okay, we can divide both by 2. So they'll get divide by 2, and they'll get the answer of uh, 14 over 6, okay? And they think they're all done and everything's great. But when in fact, both are divisible by 4. And if we divide both by 4, we can jump to an answer of 7 over 3. And that is in lower terms than is 14 over 6, okay? Now this is considered an entire fraction, and I'm going to just show you how to change mixed fractions to entire and entire to back to mixed, okay? So in this particular case, when we want to go from mixed to entire, these two are multiplied, and then it's added to the top number. So it's 2 times 3. So if we're talking about parts of 3, 2 times 3, 6 is that, plus 1. And this works out to 7 over 3. So this particular answer actually worked out right there. Okay? And then we can do the same thing here. This is multiplied, and then we add. 7 times 5 is 35. If you don't believe me, get your calculator out. Plus 3 is 38 over 5. These are what we call entire fractions, okay? The whole thing is a fraction. There's no whole number involved in them. And that gives me my answer as an entire fraction. There are many situations where working with entire fractions is better than working with mixed fractions, okay? And I would say most mathematicians actually, when you get into higher level mathematics, we leave our answers often as entire fractions. We don't change them back to mixed fractions. I don't know, it's just what they do. Okay, so here's an example though where we want to get a mixed fraction or entire fraction, and we want to change it to a mixed fraction. If you want to do that, how many times will 3 go into here? Well, 3 times 4, if you know your timetables well, is 12. And so I can subtract 12 out of there. I put the 4 here, I subtract 12 off of here, and that leaves me with 1 and 1 over 3. This is maybe a little trickier to understand. 7, how many times can 7 go into 28? Well, believe it or not, 7 times 4, sorry, into 30. 7 go into 30. 7 times 4, right, is 28. And so we can take 28 out, 28 units out, which would leave us 2 left over. So we end up with 4 and 2 sevenths. And there's no question this is one of the more difficult concepts if you're not good at fractions to work out. And so, find some practice sheets on the internet and go and do that if you're not. These are skills that, are expected for high school students. We just expect you to be able to do this, okay? All right, now we're going to move down to the next page, which is multiplying fractions, okay? In multiplying fractions, it's really quite simple. Multiply the top, multiply the bottom. In this particular case, here 2 times 5, or 5 times 2, is 10 over 6 times 3, which is 18. And of course, that can be reduced to lowest terms to be 5 over 9. We just did that one up above, okay? Now, another thing that sometimes happens is we get these things in entire or mixed fractions, and students want to just do 2 times 1 and what, like, no, you can't do that. You've got to convert them to entire fractions to be able to do the multiplication. So 2 times 3 plus 1 is 7 over 3. I believe we did that up above. And then 2 times 2 is 2 plus 1 is 3, and that's 3 over 2. And when we multiply this, we get 21 over 6, okay? And if we wanted to convert that, 18 would go in, and we'd end up with an answer of 3 times 6 is 18, leaves us 3 left over, would be 3 and 3/6, which is actually 3.5. That's the final answer if we put it into a mixed fraction form. If you did it the other way that you were talking about, you'd get 2 times 1, which is 2, and you'd get 1 times 1, which is 1, over 2 times 3, which is 6. These two answers are not the same, and this is the correct answer. This is wrong. So you must convert to entire fractions to be able to multiply them, okay? When we do division, some slight changes here. So we have 5 over 6. We must convert this to a multiplication question by flipping the back number, which is 3 over 2. And that equals, now I can do the multiplication. That's 15 over 12. And if I convert that to a mixed fraction, 12 goes in once with a remainder of 3, so you have 1 and 3 over 12, which actually equals 1 and 1/4, right? Yeah, and so I know I'm doing it a little fast, but some of this is, you are expected to know this. We have learned it this year as well as you should have learned it in the past. Again, if we're going to do a question like this one we did up here, I have to convert it to into entire fractions. Sometimes people call them improper fractions. I prefer entire fractions because they're not really improper. They're just all fraction components. So again, this becomes a 7 over 3 divided by 3 over 2. And then now I have to flip these two numbers. So it ends up being 7 over 3 times 2 over 3. And this ends up being 14 over 9. And if I was going to do this all the way down, it'd be 1, and there'd be 5/9. Okay, and that's my answer here, or here if you would like to leave it in entire fraction form. All right, let's move down to adding and subtracting. That tends to be one of the more difficult aspects for kids with respect to fractions, although there's tons of places to make mistakes when you deal with fractions, okay? First of all, when we're adding fractions, it's really quite straightforward here. If we must have what's called a common denominator. In this particular case, we do. Then we simply only add the top number. So 3 plus 5 is 8 over 7, okay? And that, of course, can be converted to 1 and 1/7 because 7 can go into it one time. We pull those 7 out, and it becomes this 1, okay? And then if we do not have a common denominator, we must create a common denominator. And usually the best way to do that is just use the opposite denominator to multiply by the top and bottom. So in this case, we're going to multiply the top and bottom by 3. And over here, we're going to multiply the top and bottom by 5. So on this side, we get 9 over 15 plus over here 10 over 15. And as you can see, we now have a common denominator, 15. It's common to both. And so we can add the tops. We get 19 over 15. And if you want to convert that, 15 goes in once with a remainder of 4. So it's 1 and 4/15. All right. And then last but not least, we could be subtracting fractions. So I used a little more complicated one here. A lot of times kids want to do, again, like they did, we were suggesting before, where they'll just subtract the tops and they'll subtract the whole numbers, subtract the fractions. And that can work. I'm not going to deny that it can work, but it's really dangerous to do. I would strongly encourage you to convert them to entire fractions, find your common denominator, and then we can work our answer back out. So let's go this way. where I convert it. So this is going to be 7 over 3, okay? And this is going to be subtract 1 times 5 plus 3 is 8 over 5. Now I need to get a common denominator, so the 3 is going to be multiplied by the 5 to get 15. So I've got to multiply the top by 5, multiply by 3, multiply by 3. And what I end up with is 21 over 15 minus 3 times 8. sorry, I apologize. What am I saying here? 21. 5 times 7. I was going 3 times 7. That's 35. I knew I did something wrong there. 35. 5 times 7 is 35. And then 8 times 3 is 24 over 15. Okay? Now I can subtract. I can subtract 24 from 35, which I believe is 11. And I have 11 over 15. And that is in lowest terms. There's nothing I can do with it. So that would be my final answer, 11 over 15. Okay. Let's do our last particular unit, or our last little topic in the first unit, which was Bedmass. And you should know what Bedmass stands for. Brackets, exponents, division and multiplication. By the way, they're together, and addition and subtraction. So when you look at a question like this, you should think, what is it that I'm going to do very first? And I'm going to do this really slow. I'm going to go with brackets first. Well, what's brackets? Right there. That's all I'm going to do. So if I do this properly, I go like this, and then I say minus 4 squared divided by 8 minus 6 times 2, and I do my brackets, which is plus 3 now. I got my answer here. That's the first thing I did. Now it gets a little trickier. What's the next thing I'm going to do? Well, it's my exponent. So because that's the next thing in line, the exponent. So I'm going to go 14 minus 4 over 5 minus 4 times 4 is 16 divided by 8 minus 6 times 2 plus 3. Now, the next thing it says you have to do is division, multiplication, addition, or subtraction. Now, there's a little tricky one here. I purposely put it in, this is technically division right here, but I have a subtraction above. Well, I can't do this division until that subtraction is dealt with. So, I strongly encourage you to do that before you even do any addition, multiplication, or division along here. But I can also do this division and this multiplication because they're sort of independent, but they're done before any adding and subtracting around them. Okay, so all of these can be done together. So I'm going to do this in one step. 14 minus 4 is 10 divided by 5 equals 2. Minus, well, should be 16 divided by 8. What's 16 divided by 8? Well, that's 2. So it's 2 minus 2. That's pretty good. Then it's minus 6 times 2. Well, what's 6 times 2? 12. And then finally, plus 3. So I get to this wonderful stage where I've got 2 minus 12 plus 3, and I can just do this all in order if I really want. But 2 minus 2 is 0. Subtract another 12 is going to be minus 12, plus 3 is going to get me to minus 9. And if you're not sure about that, use your calculator, okay? If you're going to try to put this whole thing into a calculator, I strongly encourage you to, in your calculator, put this in brackets. Anytime you have a number like that over top of something, just put it in brackets. It helps clarify for the calculator that that operation has to be done first, and it just makes it more viable. Okay, so those are the topics we did in our number sense unit way back at the beginning of the course, and that included everything on this worksheet. What do we got here? We got integers, rounding off, percentages, fractions, and Bedmass. And those kind of questions can appear on a culminating activity or unit test, or sorry, a final exam. So you should be prepared to deal with them, and this hopefully gives you a little refresher, and there'll be some practice worksheets to work on them. All right. Hope you enjoyed that lesson. We'll see you next time.